Okay, so we'll take a look at problems 24 and 25, our next page. We're going to kick this thing off with a nice little triangle congruence proof. So we'll talk about a few principles of things that are in here. And the first one is we want to remember that we always write that given information to start our proofs. And again, I will want to be very, very clear that we talk about principles of proof, and I want you to be clear that the further you go in things, people will sometimes violate this. Sometimes we'll start with something that is not the given, that's even more basic than the given information, just to remind people of some facts that are going to be an important part of our argument. But in this case, we're going to go baby steps, and we're going to say PS and QT bisect each other. Now, keep in mind, words have meanings. So the thing is by definition of bisect, we always want to use one of those fancy words. We'd like to follow that up with the definition of that fancy word. So if we have that fancy word, what does it mean? And to bisect is to literally cut into two equal pieces. And it says PS, which is this big sucker right here, and QT, which is this green guy right here, perfectly cut each other in half, which means QR has to be, because if it bisects, it cuts in half. So I know that QR is going to be congruent to RT. And by the same reason, I'm going to say that PR is going to be congruent to RS, because we literally said they bisected each other, which means they perfectly cut each other in half. Now, this is a place where different teachers are going to do this a little bit differently. My personal preference is I could call it angle QRP, but I find it far easier to call it angle 1 and angle 2. And I know that the vertical angle theorem states that angle 1 and angle 2 have to be, in fact, congruent. Now, because of that fact, I happen to know that that tells me that triangle PQR is going to be congruent to PQR. That goes from the PQR is a little interesting because I slid across an unmarked to green. So to go unmarked green has to be STR. And that would be by the side angle side postulate or theorem, because side angles, it's actually technically a postulate, I guess. But because notice we've got two sides that are marked and then an angle that happens to be smack dab in the middle. And this goes with the very last question we did, that if you ever have two triangles that are congruent, then the pieces and parts have to be congruent. And this tells me that the corresponding parts of those congruent figures, in fact, have to be congruent. And so this last one, really number 25, is just talking about that correspondence. So if we look at this, this is really the same diagram as the one that's above, just a slightly different figure. But is it true that BAC, so if you look at BAC, is it the same as E? So B to A to C, is that the same as E to D to C? See, BAC across unmarked and then single, unmarked single would be EDC. That's actually a true statement. So is angle ABC, which is this top angle, is that the same as DEC? And in fact, that is also a true statement. Is angle BCA the same as angle ECD? Well, those are vertical angles, so that's also true. Now, the thing that I don't always like is sometimes we're changing the order of those things, but angle BCA is right here, and angle ECD is also right here. So even if I reordered the letters, I'm still tracing out two angles that are in fact congruent. How about AB is the same as CD? Is AB the same as CD? Well, that's false. We didn't do that right. AB would be the same as DE. And how about BE is the same as AD? Well, it never said that, because BE is these two doubles put together, and AD is a totally different segment by putting the two singles together. So that would be an inaccurate statement. We can't really make that conclusion. So hopefully that works out okay. That'll end for that one, and we'll see you back for another one later. Bye-bye.